Welcome to today's lesson. Today we are going to look at yet another very important lesson in chemistry, O-level chemistry. In particular, we'll look at actually the physical properties of alkenes as well as the chemical properties of alkenes. This is very interesting because actually um, alkenes are more reactive than alkenes, and therefore it's important that we start their reactivity in depth. So we go straight into the lesson. Well, we'll start by looking at the physical properties of alkenes. Basically, uh, ethene, propene, and butene, when you look at their physical state, actually these are colorless gases. Actually, the alkenes with very few carbon atoms actually are gaseous in their state, while those with the carbon atoms from 5 up to 14, they are actually liquids, while those with the more carbons, starting from 15 and more, actually they become solids. So that is the state of actually alkenes. And the solubility, actually alkenes are insoluble in water, but they are soluble in organic solvents. And also their boiling point actually increases as the number of atoms increase in the compound for an alkene. And so, as we stated earlier, actually the alkenes are very light and therefore they float on water. So their density is very, very low than that of water. And the melting point actually depends on the packaging of the molecules. If it is well packaged, it means that it will be very difficult to melt it. And the polarity depends also on the functional group and the chemical structure. And so basically now we can now look at the chemical properties of alkenes after we've looked at the physical properties. Well, the first reaction that alkenes undergo is combustion, which means actually they can burn by virtue of their double bonds. So as the bonds break, actually they produce a lot of heat. And so here is a typical example for the combustion process. An alkene will burn in adequate amount of oxygen to produce carbon monoxide plus water. However, not that inadequate amount of oxygen, an alkene actually will produce an incomplete combustion, and that will, what will be producing is actually carbon monoxide. So, for example, let's look at ethene. Ethene, inadequate amount of oxygen will actually burn to form carbon dioxide and water. And this is actually the equation here we have written, where we're saying ethene plus oxygen gives us carbon dioxide plus water. So this is a typical actually explanation of how actually alkenes burn in presence of air. And so also the other reaction that alkenes undergo is actually addition reaction, meaning that actually, like here, this is hydrogenation, where hydrogen is actually added to this compound and it breaks actually the bonds. So the bonds actually for an alkene, which is ethene, in this case, is going to break. And this typically actually takes place in the presence of actually a catalyst, nickel, and you form actually ethane. Okay, and so this is a single bonded compound, while this one is actually a double bonded compound. And so this is typical not reactive. Ethane is not reactive, while ethene is very reactive. Okay. And so if we are to show the structural presentation of this hydrogenation process, we are going to have the typical structure of ethene here with the double bonds, and that one of hydrogen here with a single bond. And this one now, after breaking the bonds, is going to occupy these two areas after breaking the bond. And we still use actually nickel as the catalyst. And so here you form actually a saturated compound, which is actually a third from ethene. Okay, and so the other process they undergo actually the alkenes is halogenation. That is actually typical addition of a halogen to an alkene. And so here, for example, if we give an example of ethene, we can add actually chlorine to it in the presence of sunlight, and we are going to produce actually dichloroethane. Take note of this dichloroethane, which is actually a colorless liquid. Well, this one is a typical yellow actually liquid chlorine. And so this is what happens again here. The actually is added to this compound. Secondly, we can see again here the structure, which is halogenation, where chlorine actually is added, as we indicate in the presence of sunlight. Actually here, this is now the formation of a dichloroethane in the form of a structure, where this one breaks down. Okay. And so the other addition reaction is actually where ethane, we are giving an example of an alkene where we have ethane here. If you added water at this temperature, 300 degrees Celsius and 70 atmospheric pressure, and we put a catalytic measure here, which is actually phosphoric acid, and then we typically produce actually ethane, which is actually an alcohol. Okay, and so this is a very important reaction because actually you are producing actually an alcohol, because when you add water to ethene, you are producing actually an alcohol. The other reaction is also an addition reaction, but now this is actually addition polymerization. That is typical formation of actually plastic, and actually you need monomer units, that is small units of ethene, several of them, you add them at an appropriate temperature and pressure, and you are going to produce actually ethane, which is a single chain of a polymer actually. And so this is actually the polymerization process, the way it takes place. For example, if we have two monomer units here, this is ethene, again, this is ethene, and this one is going to break. So we're going to have now a single chain with one bond each here. And the number, remember the number of hydrogen atoms here, it should be the same, 1, 2, 3, 4, 5, 6, 7, 8, similarly here. And so this is actually a polymer, which is polyethylene, which is a typical plastic. I thought we would look at this as well as looking at actually the uses of plastic. Since actually this is now a single bonded, as we said, this is an alkene, so it is not reactive, and that's why you see that we have a lot of litter of plastic bags around in the dust bins, okay, where actually these plastic bags, unless you take them again for melting, they cannot rot because they are not reactive. I thought today we'd look at the properties of alkenes, and I thought this would help us so that we can typically learn of how these actually react. I hope you continue subscribing to my YouTube so that you can learn more of these lessons. Thank you.